Good morning, everyone. My name is Raghavan. I am presenting a do-it-yourself semantic code search today. A quick introduction about me. As I said, my name is Raghavan. I'm a senior engineering manager at LinkedIn, leading the search AI team. So if you're searching for something on LinkedIn, that's powered by my team. I am also a volunteer for the GenAI Commons on Linux Foundation, and I am an active hackathon participant on LabLab.ai. The views that I am presenting today are all my own, and I am not representing my employer. Let me first pose the problem to you. Let's say you are a developer or you are a senior engineering leader who has a lot of developers. And imagine that you or one of your developers are trying to contribute to a new code base for a beginner task. Just knowing which file to change, where to make these changes can be very time consuming. And I'm not talking about the code completion task. Like code completion is as you're typing code. You have There are lots of applications nowadays to complete the entire piece of routine or the entire code. I'm not talking about them. I'm talking about a search task where you are given a description of the task, and you need to know which file to change, where to make those changes. We have all been there. That It's, let's say you are a enthusiastic new developer, but you're overwhelmed. Just knowing what to change, where to change, going through that maze of new code base can be daunting. I developed this application maybe a year ago as part of Open Repetitive Hackathon in LabLab.ai, later in Codestral Hackathon, under the name Codebase Buddy. Now, how did I get the inspiration for this application? It's because the most common 101 RAG application that you see on the internet is Talk to Your PDF. And the application goes like this, which is you have a PDF, and then you chunk them into several small chunks, and then you generate an embedding for each of that chunk, store that in a vector store. And when you have a question, which is what you are trying to talk to your PDF to learn more about that PDF, you ask the question. Vector store retrieves the relevant chunks through some nearest neighbor search that are relevant to that question. Actually, the question gets converted to an embedding, and then you do a vector search, and you retrieve the nearest neighbors that are relevant to that question. And then you send that to an LLM and prompt the LLM to generate an answer. I was thinking, why don't we do the same for a local repository where you break down the contents of a repository into smaller chunks? And the chunk could be a file, and generate an embedding for each of that file, and store it in a vector store. When there is a question, you again do the nearest neighbor search to get top k chunks or files, and then send it to an LLM, and you get your answer. Simple, right? So again, I want to go back to the problem. The problem is I am trying to solve for when you have a question or a beginner task or some task. I'm trying to solve for the problem of which file to change, where to make the changes. That's why and I'm trying to uh, do a do-it-yourself semantic code search. Cool. Now, inspired by the talk to your PDF, let's say you have done this, and I saw Llama Index's beginner Hello World example, and then I thought, why don't we just repurpose that for a simple talk to your code base kind of semantic search? It's a simple 33 line code where all I'm doing is I'm not going to go into this because these are just imports and then getting a directory and a query, and I am trying to create a vector store from these documents, from the documents, which here documents are basically contents of your repository. And then when there is a question, I'm creating an index, and then I am getting a response from, I'm querying that index and getting that response. Behind the scenes, this is doing nothing but getting the relevant chunk and call the LLM, prompt the LLM to get the answer. So what I did is, this is the beginning, at the very beginning, which I'm explaining my journey. So there is a popular repository called Local GPT. It's a popular open source repository, which is again how to use GPT models on your local device to chat with your documents. And it's a popular repository. I would like to I would recommend. Feel free to check this repository out. I wanted to build a talk to your code application or a code search application for this local GPT based on the 33 line code from Llama Index. So, and this is the 33 line code. And as I showed earlier, it's not doing nothing, but it's asking for a natural language query, and it's asking for the location of the directory where your code base is. And then if it's the first time, then you create an index. If it's not the first time, you are loading the index and you are just querying that index and generating a response. So I asked a simple question of, I have my local GPT in my Mac, and I'm going to run this file llama-buddy.py. I'm asking a file, which file should I change to add support to Falcon 180B model? So local GPT supports a lot of models, and I am asking a question, which file should I change? Remember, the application that I'm trying to build is, I just need to know which files to change and what to change, how to make the changes. I get a quick response of, to add support to Falcon 180B model. I'm asking a hypothetical question. It's very difficult to deploy a 180 billion parameter model on your laptop, but I'm asking a hypothetical question of, in my local GPT repository, which file should I change to add support for Falcon 180B model? And this simple 33 line code gave me, to add support to Falcon 180B model, you should change constants.py, model, update the model ID, model base name, there, etc. And then make sure to follow the guidelines provided in the context for selecting and setting the model ID and model base name based on the model type, quantized or unquantized. I also asked another question of, instead of Falcon 180B, say Llama 3.1. Then for that, okay, you should change the constants.py file to add support to the Llama 3.1 model. Now going back to our presentation, this is what I got, which is, to add support for Falcon 180B model, you should make changes to constants.py. What is missing in this? What is missing in this is, or I should say, what can be better? I would love to get a detailed answer, list all the files that are needed as much as possible, and give instructions of what to change within the file. It would not be useful just to get, hey, you should change constants.py to add support to Llama 3.0, or you should change a constant.py, update the model ID and model base name. Is slightly more explanatory than this answer, but it isn't giving me a list of files. If it could be better, a more detailed answer listing all the files and what needs to be changed. So the solution is very simple, which is, traverse through the entire repository. For every file, generate an embedding and store that in the vector index based on its content. The embedding should be based on the content of the file. And then query the vector index, get the top K files. You can leverage an LLM to generate an answer. So how do we do this? Which is, you have a GitHub repository. Let's say you can use sentence BERT embedding, or you can use OpenAI's ADA embedding, and then you can store the embeddings for each file. Build a vector store by generating a embedding for every file based on its content, and then store them in the vector store. And then at the time of retrieval, when you are asking a natural language query, you can query the vector store, and then you can get the top K files that match that query, and then concatenate the content, and then you can prompt a large language model to get the instructions. Let me quickly go to the code where I have. So the code is very straightforward. I am using sentence BERT here, or you can use OpenAI's ADA embedding. I am getting all the files that match, .py, .sh, or .java using this routine. And then for each of the file, I'm getting the contents of the file. And then after I get the contents of the file, all I am doing is I'm using the sentence BERT model to encode and return an embedding. And then I'm using Annoy. Annoy is an open source vectors. Annoy is an open source vector store that can be used to create a vector store locally. And then all I am doing is I'm creating an Annoy index using Angular metric, Angular as the distance metric, and then I am saving the Annoy file locally. So straightforward. And I tried this for LangChain. LangChain has more than 4,000 files. Um, and I asked a question of where should I make changes to for the new summarization prompt. And I was able to get the very relevant files that are necessary for making the changes to, if I have to make a changes to add a new summarization prompt. Similarly, so for example, if the thing that I would love to highlight here is the word summarization exists in the third file, entity summarization, so it doesn't matter. But you can see, because we are doing a vector search, it was able to retrieve refined prompts, tough prompts, map reduce prompt. All of these prompts are related to summarization. And as I said, this will improve the productivity of a beginner engineer, um, or even for an expert engineer, just if they are rusty on the code base. Similarly, I tested this for Llama Index, where I asked a question of similar to Elastic integration. If I have to make changes to support Apache Solar, how do I make the changes? And I was able to get a clear answer of, hey, these are the files that you need to make changes, which is the base.py in readers, followed by text splitter, followed by you can see that it showed both text files, it showed both development files and test files. So let me do a quick code walkthrough for this. So this is how you build the index, which is nothing but you create an anno index, you traverse through every file, and then you get the contents of every file, and then you generate an embedding for every file, and then you can just add it to an anno index, and then store the index locally. And then at the time of retrieval, let's say uh, at the time of retrieval, all you have to do is I'm going to show a demo. All you have to do is you can query the annoy index for the top K files using the same embedding size. And then once you get the files and the corresponding IDs, then all you have to do is concatenate the contents of the file, and then send that one giant prompt to say GPT-4, and with prompt saying, hey, summarize the purpose of the file for each file, identify what changes need to be done to accomplish the task specified by the user. So the user's question here being user's question and the concatenated content. So I had this run locally. Yeah, I had this run locally. So I'm going to test this. Say the question that I had was, where should I make changes to add a new for a new summarization prompt? Where should I make changes for to add a new summarization prompt? And I'm using LangChain as the index. So you can see that it retained refined prompts, it retained entity summarization.py, and it retained mapreduce prompt.py, stuff prompt. All of these are related to summarization prompts on LLM. And then here it gave a clear answer stating that, hey, refine prompts, this file defines prompt templates for refining existing summaries. And then it includes a prompt for enhancing an existing summary with new context and template for generating concise summaries. Similarly for entity summarization. And an important thing is this MapReduce prompt is a prompt that is generated summary of summaries, and stuff prompt is another file that needs to be changed if you want to add a new summarization prompt. So here you can see that this is the vector search pod that retrieved the relevant files, and after that I used a large language model to just send the contents of that file with my original question and with a prompt that is solving for my problem, where I get a recommendation. This solves my problem. That's great. And I tried this for LangChain, and then I tried this for Llama Index. I was able to see some good results. This definitely improves my productivity. Now, if you see, I have used SentencePert for embedding, and then Annoy for the vector store, and I use GPT series. But you can actually do this with fully closed source solutions or fully open source solutions, or a mix and match of both, like what I did. Like you can use OpenAI's ADA embedding, you can use GPT series LLMs for the generation part, or Claude, or there are so many vector stores available that you can use to build a solution like this. If you want to do purely open source, then you want to leverage that is something that is purely open source. You can try SentenceBird, Code-T5. Yeah, I think Code-T5 from Salesforce is open source. Yeah. And then Llama models, or Mixtel, or E from 01.ai. And there are so many vector stores. I used Anoi for the purpose of this demonstration. What I am trying to show today is I am saying that you can build your own do-it-yourself code search tool to improve your productivity without having to rely on any other solution. Now, if you see, I used OpenAI's GPT-4o, right? Can this be done locally? We can actually build this locally with purely open source solutions. I can continue to use SentenceBird for the embedding part, and then instead of using GPT-4o, I can actually use Olama. Olama for local LLMs. What exactly is Olama? Olama is a platform that is designed to facilitate the use of large language models like Llama 3.2, Mistral, Gemma, etc. on your laptop. With just as simple as pip install Olama, you can start to use Olama on your laptop. I think Olama is also available for multiple operating systems, including Mac OS, Linux, and Windows. For example, I have installed Olama, and then you can see that when I did, I'm going to close this so that I can show from scratch Olama list. I have E from 01.a, Mixtral and Mistral and Llama 3, DeepSeek Coder, Cholesterol, all on my machine. I can choose to run one of them locally. For example, I just did Olama run YI. It is which means that I'm deploying Olama run Olama. I'm using Olama to run the E large language model, and it is on my terminal. The E34B model is running, 34 billion parameter model is running, and I asked it a question of who is the president of US. As of my last update in June 2023, the president of US is Joseph R. Biden Jr., who has been in office since January 2021. So now I can ask who is the cat. Let's see. What is the capital of Washington? Sorry, US. Yeah. This application is not related to code search, but I am trying to show this as a demonstration of I have a large language model deployed on my machine locally. I can actually pull the plug of the internet, and this would continue to work because this is deployed on my machine. So now going back to the representation, once you have Olama, yeah, I have a screenshot just to show, just in case if the demo gods were not with me, I wanted to show that you can use Olama to have deploy large language models locally. Now, why was I talking about Olama? In the solution that I had, I was using a large language model. So standard RAG pattern. I have a query, I have a vector store, get the top K files, concatenate them, and create a custom prompt, send it to large language model. If I am privacy focused, if I do not want to use or either privacy or I don't want to use GPT series models for the purpose of reducing cost, Olama is a good alternative to use large language models locally. So, but there is a problem here. The problem is most of these large language models that are part of Olama as of today uh, have smaller context length. They do not have the large context of say 100k plus that comes with from closed source LLMs, and as a result, you may run into context length or token limit issues. And a way to circumvent that is you can retrieve the top k results from vector search, and instead of sending all of them at the same time. For example, in this solution, you may see that I get the top k files, concatenate, and prompt them instead of sending all of them at once. You may have to do multiple calls, send one file at a time with the prompt, and get the response from Codastrol or locally deployed Llama X or E, and then you have to repeat this for k files. Uh, so in the original solution, when I ask a question, I was calling the vector store. I was getting the top k files. I concatenate and created a prompt, send it to GPT, and then I got the answer. But now it's all in one versus one at a time, where I am calling the same vector store, getting one file at a time, and then I'm sending one file at a time to this LLM that is running behind Olama. Maybe let's say I use Codastrol, and then I generate an answer. So I did this. I have this screenshot just to show that it worked, but I'm also going to show the same question of where should I make changes for summarization prompt. It got the same set of files because remember I did not change the embedding model or the vector store. It's only the large language model part that I'm using Olama. And then I'm getting a summary for each file where I get a clear summary for what's the purpose of refined prompts, and then the changes that I need to make. Purpose of entity summarization.py. It's a file purpose and functionality. Necessary changes that I need to do to accomplish the task. Similarly, the third file and the fourth file. Let me see if I have. Yeah, I have the demo here. You will notice that this is far slower than GPT-4 because the model is running locally on my CPU. So the retrieving the first four files would be faster, but after that you will see it's taking time because it's using Olama Codastrol behind the scenes. It's running on my CPU. It's going to be slower. It's not going to be as fast as the online call that I'm hitting OpenAI endpoints because it's running on CPU. It's going to be slower. Now going back to the demo. So let it run, and I'll show. And in the meanwhile, I'll talk about the pros and cons. The pros and cons of using a locally deployable model is it's open source and it's not expensive and it's locally available. The con is that the combined context is missing. Remember, you see, in this example, I send only one file at a time instead of multiple files. So because I'm sending only one file at a time, the combined context is missing. At least in this solution, it is solvable if you can use a large language model with sufficiently large context, say for example E34B, or let's say, and then the other con is GPT-4 whose quality is definitely superior compared to these models, and I have seen some increased hallucination. Um, so let's see if in the meanwhile if this is done. This is slow. That's another con because of this is running on my local box, and that's why I had a demo. That's why I had screenshots prepared earlier to show that I have that this is working. Now going back to the presentation, what is the advantage of a solution like this, like Codebase Buddy, the talk to your code? New contributors can actually get up to speed with Codebase, reducing onboard time. If not, these contributors will have to ask the senior most engineer of the team and require some guidance. And because there is so accelerated onboarding. Second is it reduces errors because there is some very specific guidance. Newcomers are less likely to make mistakes. Third advantage that I see with a system like this is increased engagement. This encourages people to do more contributions from the community, and then even for experienced developers, it's a form of continuous learning. The tool can be a means to discover and learn about the lesser known parts of a code base, even if you are an expert developer. And then lastly, I see this as another documentation aid. The system can help identify which parts of the repository requires additional documentation or the documentation is outdated. So I plan to extend this in the future, where instead of just generating an embedding for every file, I want to chunk at method level so I have more granularity. And then I would like to see if we can use knowledge graph instead of vector search. And third, I want to use a local LLM that's fine tuned for this repository or the particular repository that I'm working on. Cool. With that, I'm concluding my presentation. Thank you. And let me check in the meanwhile if I got the content generated. Yes. As you can see, oh, my bad. As you can see, it was generating results for one file at a time. This is a previously generated screenshot. Sorry, a previously generated tab where it was able to generate one file at a time. It is slower compared to GPT-4o, but you get privacy. With that, I'll conclude my presentation and open it up for any questions.